All right, in this video we continue looking at the differential identities of Bessel functions. In a previous video we have derived the first one. In this video we're going to derive the second one here. So again, starting with the series definition of Bessel functions, we're going to multiply this by t to the power negative nu. So multiply this by t to the power negative nu. Then we're going to have minus nu there. So that means what's going to happen is that this is just going to be t to the power 2m. And then differentiating on both sides. So this is what we're going to end up with. So by the way, is the same as t to j nu divided by t to the power nu. So this is going to be 2m negative 1 to the power m t to the power 2m minus 1, all divided by 2 to the power nu plus 2m m factorial gamma of nu plus m plus 1. Then what's going to happen, this 2 is going to divide into this term, so we can just take the 2. This m is going to divide with this one. We're going to end up with m minus 1 factorial there. So that means in the next step, this thing is going to be the summation of negative 1 to the power m t to the power 2m minus 1 before we get there. Here, because of the m here, even before we cancel, so I'm just redo this. Yeah, so before we cancel there, we've got m factorial and m there. So that means this term is now 0 when m is 0 because of that m there. So it means our lower summation index is going to have to go up to 1. Okay, and then of course we cancel. So this goes, that becomes m minus 1 factorial. So that means this lower summation limit now is 1, and then this is divided by 2 to the power nu plus 2m minus 1, m minus 1 factorial gamma of nu plus m plus 1. Then we're going to have to change our dummy variable. We are going to introduce n is going to be m minus 1, which means that m is n plus 1. So then what's going to happen at the lower summation limit, when m is equal to 1, n is 0. Okay, because as m goes to infinity, n goes to infinity as well. This is now going to be negative 1 to the power n plus 1, and that's going to be t to the power 2m minus 1. So let's work that out here. So 2m minus 1 is going to be 2 into n plus 1 minus 1. 2n plus 2 minus 1 is going to be 2n plus 1. Okay, so every 2m minus 1 becomes 2n plus 1. It's going to be 2 to the power nu plus 2n plus 1. M minus 1 is n, so it becomes m factorial. And then there's going to be gamma of m is n plus 1. So it's going to be nu plus m plus 2. All right, we're almost there. So what we're going to do at this point is we are going to factor out one of the negative, the plus 1 there. So we're going to factor out the negative. We're also going to factor out 1 over t to the power nu, which is what we multiplied by initially. So we're now going to have negative 1 to the power n here. This thing is going to be power nu plus 2n plus 1. Okay, I think let's do it like this. So I'm going to write this as nu plus 1, then plus 2m. Okay, then in the denominator, going to write this as nu plus 1, then plus 2m, 2n, n factorial. I'll write this one as nu plus 1 plus m plus 1. All right. Then this is now exactly the same as what we started with here. Let me just remove this. So what we started with here is this. Okay, now if you replace every nu by nu plus 1, so nu plus 1 here, nu plus 1 there, nu plus 1 there, then you have got what we have there. So this is telling us that this is j of nu plus 1. So so finally we have negative j of nu plus 1 divided by t to the power nu, which completes the derivation for this second differential identity of Bessel functions. All right, thank you for watching. Hopefully it's been helpful. Please do subscribe to support the channel so that we can produce more material of this nature. Thank you.